Let's look at section 5.4, indefinite integrals and the net change theorem. Last time we learned the fundamental theorem of calculus part 1 and part 2. Part 2 was definitely the more important part, right? They both said that, one said that the derivative of the integral is the original function. That's what part 1 said. Part 2 said that the integral of the derivative is the original function. Part 2 is definitely more important, and it's what you're going to be learning a lot more of in calculus 2. And so we're going to focus a bit more on part 2 in this section. We're going to define a generalized version of the integral called the indefinite integral. Integral. It's indefinite integral of a function. And it's the integral notation, but it doesn't have bounds, right? And that's going to be that, right? And of course, the answer is going to be just the antiderivative plus c, right? So it's just going back to section 4.9, really, right? Anti-differentiation. So when I ask you to find just the integral or the indefinite integral, you're just anti-differentiating and you're adding c, right? So for example, find this indefinite integral, right? I don't want to rewrite all that, but let's just simplify this a little bit because we're going to need to do that in order to integrate. This is going to be the same. Let's just rewrite this as x to the 2/3. Let's rewrite this fraction as x squared minus 2x to the negative 1/2. Pause the video if you don't see how I got that. But what I did was I split the fraction. And then we write dx at the end. And then we just integrate term by term. Now, WebAssign can be a little bit whiny about, using absolute values. But you can just write ln of x with parentheses. I don't care. Whoops. And anyway, we just have this and then this. So this is going to be what? Plus. So it's just going to be x to the 5/3 and then divided by 5/3 or times 3/5. And then I guess this is going to be 1/3 x cubed. What's that going to be? Plus 4 x to the 1/2. I think it's actually minus, right? Because I just took the derivative, right? I got that, right? And then, of course, we write plus c. And that's our answer, right? So this is just another way of saying anti-differentiate the function, okay? For number 2, right, this is a definite integral, right? So we do write bounds, although we don't write the plus c thing, right? We don't need to do that. We just have, okay, this is going to be 1/3 x cubed. I guess what's this going to be? Minus x to the negative 1, right? Yeah, minus x to the negative 1. And that's going to be from 2 to 5. And of course, we could rewrite this as 1/3 x cubed minus 1 over x. I just think it's a little easier to sort of visualize what's going on there. Anyway, plug this stuff in. What's this going to be? 1/3 times 5 cubed minus 1/5 minus 1/3 times 2 cubed minus 1/2. That's our answer. You could simplify that, right? We could simplify that. I'm not going to bother, but you can simplify that. Okay. All right. So we have that. One thing that we learn in this section is something the book calls the net change theorem. This is just conceptualizing the integral, right? The same way that we conceptualize the derivative, which was, if you were given a position function, the derivative of that position function was the velocity. The integral is the opposite of that, right? If we're given the velocity function, the integral is the position of that function, right? The position function of that object, right? And also just to point out the difference between net area and just total area, or net distance and distance, right? When the curve is above the x-axis, the area is considered positive. When the area is below the x-axis, the area is considered negative, right? And so the net area of a curve corresponds to the, you could say, displacement or net distance of a particle with a certain velocity. And so the net change theorem just says the integral of the rate of change is the net change. In other words, what we've always had, right? The integral from a to b of f of x dx equals the antiderivative with b plugged in minus the antiderivative with a plugged in. That's what it means. That's it. If you're ever asked for the total area under the curve, then that treats all regions as positive area. And so then the total area under the curve corresponds to this idea of total distance, right? So if you walk forward 5 feet and walk back 5 feet, your net distance is 0. Or your displacement, so to speak, is 0, right? But your distance is 5 plus 5 equals 10 feet, right? So just to illustrate this very quickly, we have something, let me not do that. Let me do something like this. If we have a curve from A to B, we'll call this guy A1, A2, and then that right there is A3. So we would say displacement or net distance equals A1 minus A2 plus A3, right? If you were to find each of those areas. Distance equals A1 plus A2 plus A3. And so the question is, how would you write an expression for that? Well, you'd write an expression for that is you would just say, if displacement equals the integral, then distance equals the integral from A to B of the absolute value of f of x dx. And the annoying thing is that you can't, there's no nice little formula for that. What you need to do is you need to find the zeros. You need to find where the curve touches the x-axis. And then just make sure that and then just split the integral up into each of those things. And if the function, if the integral is positive, then just keep it that way. And if the integral is negative, just flip the sign and then add it all together. So for example, in example 3, we have a particle moving across the line at time t with this velocity. Finding the displacement, that's not quite so bad, right? We'll just say displacement equals the integral from 1 to 4 of v of t. And so this is just going to give us 1/3, right? We're just anti-differentiating, right? And then we're going to plug in 4, subtract, plug in 1. Minus, plug in 1, right? Right, so we have that. And you could simplify all that out, right? Just simplify that out, right? All right, what about the distance? Well, the distance just takes a little bit more work. Not any more calculus work, but a little bit more algebra work, right? Because we have to find when v of t equals 0 and then split the integral up at those points. So we're going to let v of t, which equals t squared minus t minus 6 equals 0. So t equal, or so, I guess I'll just say so v of t equals, what's that going to be? T minus 3 times t plus 2, 0. So v of t equals 0 at t equals -2 and 3. Now, if you notice, we're integrating from 1 to 4, right? T is between 1 and 4. So you don't need to worry so much about -2 because it's not in our interval. Let me just put it here. Right, that's why we are Xing that out. And so we just worry about 3. So what we're going to find is that distance equals the integral from 1 to 4 of the absolute value of v of t. And that's going to be the integral from 1 to 3 of v of t dt, dt, plus the integral from 3 to 4 of v of t dt, right? And I guess at this point, I should say that because we've split this up over the zeros, we can put absolute value signs outside the integral. Okay? So let's just do this integral out, and we'll see what we get. If we get a positive number, keep it positive. If we get a negative number, flip it to make it flip the sign to make it positive, right? We already know what the integral is, right? We already did that, okay? We just need to plug in different numbers. So we'll get 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 3 plus, I can do this again, from 3 to 4. And we do this, I think it's pretty clear that this first term is going to be positive, right? Because this, oh, no, that was right. Yeah. This right here, whoop, is just clearly bigger than what you subtract. And then we get plus, and then I guess this right here is going to be, I guess this right here looks like it might be negative. No, actually, no, I think I take that back, actually. No, I think I take that back. I think this is going to be kind of big. I think this is actually going to be negative. Well, let's see. Maybe I'll take all of it back. I'm not sure it's clear. Let's dive in a little bit. Right? Right, we're doing, this is the absolute value of this, right? Absolute value, absolute value, absolute value, right? So let's see what we're getting here. I think we're getting, this is 9 minus 9/2 minus 18. Actually, that's negative. Never mind, we're negative. Minus, and then it looks like we're getting 1/3 minus 1/2 minus 6. And this is going to be a little bit close, actually. But 9/2 minus 18, so this 9 minus 18 is negative 9. Minus 9/2, I think we're getting negative 27/2. And then this is going to be minus, well, I guess it's going to be minus 1/2, so minus 6.5. I think it's plus 6 1/6. 6 1/6, which is 37/6. No, so, but this is really, if you multiply this by the negative, 81/6 plus 37/6. So I'm getting, was that 44/6? Negative 44/6. So I lied. This is actually negative. Okay. And then this right here probably should be positive. Let's just do it out to make sure, right? 64/3 minus 16/2 minus 24. I'm not even sure. Let's see. Minus 9. And then that's minus 9/2 minus 18. Yeah, this is also going to be a little bit close, but I do think it will be I think it'll be positive, right? Let's see what we get here, right? We're getting, right, this is really the same thing as 8 So this is minus 32. I'm not sure, right? This is minus 32. 64 thirds minus 32, which is minus 90. So this is negative 32 thirds minus, and then this is really going to be, let's see, it's going to be minus, it's minus 9. So I think it's really plus 27 halves, right, which is greater than 0. Right, so just keep that the same. Okay. So distance equals 44/6, which I guess is really 22 thirds plus, or I guess this is minus 32 thirds plus 27 halves, right? Which equals, right, whatever. Let you simplify that, right? So one more example like this, right? Let's just do one more example, right? Set this up, right? Displacement, pretty straightforward. Right, the hardest part of that, by the way, was the simplification, right? There's just the integral from 0 to 5 of this, right, which is going to be this, right, which is just this. Right, and then plugging in 0 is going to give us 0, right? Okay. But the distance, well, to find the distance, we really need to find when, actually, let me move this down. We need to find when the polynomial equals 0, right? So v of t equals t squared minus 2t minus 8, which equals t minus 4 times t plus 2 equals 0 at t equals 4 and negative 2. Well, of course, we don't care about negative 2. That's not in our bounds. But 4, we do care about that, right? So we integrate to the distance equals the integral from 0 to 4 of our function in question, plus the integral from 4 to 5 of our function in question. All right, and we're taking the absolute value, right? So if we get a negative number for either of these, we just flip it to the positive number, right? So anyway, we get 1/3 t cubed minus t squared minus 8t. Plug in 0 and 4. Well, this is obviously positive. I am sure about this time, right? Right, 1/3 times 4 cubed minus, well, actually, am I? I don't even know. I think I might even take that back again, right? Because this is minus 32. Nope, I lied. I lied again. See, my intuition's way off, right? This is 64 thirds minus 48. So we're taking absolute values of these, right? Which really equals 48 minus 64 thirds. All right, okay. Meanwhile, this equals right, and this probably will be positive, just the way that these curves tend to work. But let's just make sure, right? Right, and then this is going to equal 1/3 times 5 cubed minus 5 squared minus 40 minus, right, and then this is 1/3 times 4 cubed minus 4 squared minus 32. Now it's going to be a little bit close. Let's see what we get here, right? This will be 125 cubed minus 65 minus 64 over, oh, no, not 125 cubed, sorry, 125 over 3 minus 64 thirds, but then this is going to be plus 48. So it'll be a little bit close, but I think this is positive, right? 125 minus 64, that's going to be 61. minus 17. Yeah, that's definitely positive because that's minus 54. I think that's 8/3, right? So distance equals, this is plus that, right? So it's going to be 48 minus 64/3 plus 8/3.